All right, so I got cut off on the first video. I wasn't paying attention to my time. So I had already recorded and drawn out this word problem, and then I had to trim the video. So let's go back through it. Lena stands at the top of a 121-foot lighthouse and looks down at a sailboat that is 422 feet away in the water. At what degree is Lena looking down from the horizon? Okay, so let me walk you through the sketch that I did. Here is the lighthouse. Here is Lena. The lighthouse is 121 feet. Here is the water, and here is the boat, and the boat is 422 feet from the lighthouse. So here is Lena. If she was looking straight ahead, right, if her eyes were just looking straight ahead, that eye line, that eyesight would be level with the ground, okay? But instead, her eyes are tilted down, and that is the angle of depression, looking at the sailboat. Sketching this out, we have a right triangle here, and I find it easiest to transfer my angle of depression measure, which we don't know what it is yet, to my angle of elevation, because like I discussed, the angle of elevation is congruent to the angle of depression due to the alternate interior angle conjecture. The reason why I do this is because when I'm looking at the triangle, it's easier to make sense of it if I'm looking at the angle of elevation here. And then I can identify the lighthouse height as my opposite and the distance between the boat and the lighthouse as my adjacent side, which you can see I labeled as O and A. And so to find my angle measure, I'm just remembering that the tangent of that angle measure is equal to the opposite over the adjacent. So then to find the angle measure, I use the tangent inverse of the ratio. So the angle measure is equal to the tangent inverse of that ratio. And then when I punch that into my calculator, I got roughly 16 degrees. Again, to check this answer, I could take the tangent of 16 and I get approximately 0.2867. And if I punch in 121 divided by 422, I should get this same ratio. All right, so we have just our last examples here. Let's take a look at those. Again, feel free to pause the video, work them out, and then check my answers, or just go along with me and write them down as I'm doing them. We have a right triangle. All right, and it has legs length 8 and 15. So 8 and 15. Find the measure of the angle opposite the 8-inch leg. So here's the 8-inch leg. Here's the angle opposite. We will label that as X. So to find that measure, again, 8 is the opposite, 15 is the adjacent. So the tangent of that angle measure will be 8 over 15, which means the angle measure is the tangent inverse of that ratio. Tangent inverse of 8 over 15 is 28 degrees. So it's about 28 degrees. For number 2, we are finding the measure of angle Z. So Z is the base angle of an isosceles triangle. So this is, again, another problem where we are bringing in content that we learned much earlier in the course. This is actually from chapter 4, because we know that if we have an isosceles triangle and we have an altitude from the vertex angle, that is also the angle bisector of that vertex angle, and then it's also the median to the base. And so exploring this triangle right here, this distance is 6 centimeters. So to find Z, this is our adjacent, and then this is the hypotenuse, because again, it is the opposite of the right angle. So which trig ratio deals with adjacent and hypotenuse? It's cosine. So the cosine of Z is going to be 6 over 25. So to find Z, we take the cosine inverse of that ratio. So it's 6 over 25, and it's about 76.1 degrees. In our next one, x, again, is this angle labeled here. This value, 17, is the hypotenuse, and this value here, 15, is once again the adjacent. And so we're going to use cosine again. So the cosine of x is equal to 15 over 17, adjacent over hypotenuse. So x is equal to the cosine inverse of 15 over 17. And that gives us about 28 degrees. So interesting. Okay, I'm going to bring something up here. Did you notice something? It is very close to the same answer above. Why is that? Well, there is a Pythagorean triple with 8, 15, and 17. Okay, and that's why we ended up with the same angle measure, even though we were doing a different trig ratio. If I do 8 squared plus 15 squared, I get 289, and that is equal to 17 squared. So another thing when we're doing these, you don't have to use the two sides given to you. You can use the Pythagorean theorem to find the third side and then use a different trig ratio to find that angle measure. Well, this is it. This concludes our trigonometric lessons, and you finished geometry and all the content, and I'm just really, really proud. Great job.